first, a little bit about the Marine Debris Program, who I work for and with. So we were established in 2006 by Congress as the federal lead for marine debris as a topic. There's the recognition that this was a specific topic that needed more focus and more effort. So the vision, the concept is that we have the global ocean and its coasts free from the impact of marine debris. Well, obviously we're not there yet, and we're working towards it. But that's we set an ambitious goal as the target, but we want to work towards that. So part of how we approach that is through regional coordination. So having staff whose role it is to understand a specific region and work with that region and the community that exists in that region around the topic of marine debris to understand what's going on, what the needs are, what the challenges are, but also what the successes and opportunities are. There's one of the key things that I try to really emphasize and focus on is that there's an active and innovative marine debris community, especially in Alaska. But there's pre-existing communities, people that work on the issue of marine debris, whose first job might be working on a specific species. They're a seabird person or a marine mammal person, or they might be focused on a geographic area, like they work for Park Service or Fish and Wildlife Service in a park or a monument or a refuge. But then they see an impact from marine debris and they get engaged and do groundbreaking work. So it's like their second or third or fourth job marine debris is. We have in the Marine Debris Program, marine debris is our first job. It's our primary job. However, we're just part of that community. We just have the luxury of it being our first job. And so the way I view it is, part of our core role is supporting that community, because so many times there's such great knowledge and effort and outputs, the results that come out of the groups that really do a lot of the work. Within the program, the way we kind of divide it out is we have kind of pillars, we call them, removal, research, prevention, and response. So response is kind of what the response to this incident we're dealing with right now, that would fall into. Sort of the idea of a lot of the debris that goes into the world's oceans goes in as a result of chronic everyday decisions or behaviors, things that get improperly disposed of on land or at sea, things that kind of just happen here and there, or the leakage out of infrastructure and solid waste systems. But those are kind of little by little, a little bit at a time. But there's acute events like what we're seeing here in the Bering Strait recently, where you have a whole lot of debris go in the ocean at once, and that can be different in different places. So we'll get more into each of these in a moment. So practically, when we say marine debris, what do we mean? Well, marine debris is, so of course, working in the federal government, we have a legal definition that the Coast Guard and NOAA came up with back when the program was established, which defines it as any persistent material that is disposed of or discarded into or lost into the marine environment or the Great Lakes. So it's inclusive. But practically what that looks like, I've just included a few things on this slide. It goes from the micro to the macro. So everything from that micro bead on the person's thumb there in the top center, those have now been primarily outlawed, and that would be a large example of one, but it's an intentionally designed small microplastic. So anything less than 5 millimeters is a microplastic. There's a lot of press happening around those, that people are finding microplastics in all sorts of places and environments and substances, and biota as well, which is causing, of course, as it should, concern. But it goes from there all the way up to large items. So at the left, that's kind of a typical, a lot of times people think of the garbage patches. They think of an image like that. Obviously, that's a lot more concentrated than a garbage patch would be, but it shows an example of, a lot of consumer debris that we see, And then at center, that's actually Dungeness crab pots from Southeast Alaska, just outside Juneau. I know we had a caller from Juneau. That shows, that derelict fishing gear can be a significant part of that, whether that's nets and line, which we see more of in the Bering Sea region, or crab pots, which we also know occur in the Bering, but are obviously deeper and harder to get to. But also everything all the way up to derelict vessels, abandoned derelict vessels. That's an image from Alaska as well, showing just examples of vessels that people could no longer take care of or didn't want to deal with anymore, and they get grounded and abandoned, and then they're left and can continue to break down and release additional debris into the environment over time. So Debris types, again, one thing I want to, plastics is the most common form of marine debris, because it's something that's non-biodegradable. The same thing that makes plastic good to use makes it a challenge in the marine environment. It's lasts a long time, and it can modified or designed to meet, modified or engineered to meet a lot of different needs, flexible, rigid, different colors, all sorts of things. It's really good at those things. The problem is that when it gets in the environment, those same things are problematic. It's estimated that 8 million metric tons of plastic enter the ocean every year, and much of that can, over time, break into smaller and smaller pieces. Plastic only breaks down by a photodegradation, so light hits the debris, hits the plastic, the chemical bonds become weaker, and then they break apart, but then you just end up with smaller and smaller pieces of plastic, rather than something that actually becomes its component chemical elements that can then be ingested to provide energy, like you would see with biodegradation of an organic material. Microplastics, again, I mentioned, plastics are smaller than 5 millimeters in size. That top image is one I took from a small bit of styrofoam on a beach in South Central Alaska, out at Gore Point. But that shows just that, whether it's foam plastic or solid plastic, you can break down to these smaller and smaller pieces. So it can come from different sources. You have micro beads, microfibers from fleece or other synthetic materials. Fabrics is a really area where we're seeing a lot of debris. So a lot of times when you see microplastics detected, it's often microfibers. But you can also see pre-production pellets. So the feedstock that are used to make large plastic items, those are pre-production pellets, and then they're melted and cast into the plastic objects. So when those are lost, that can cause problems. But also you can see microplastics, even if they weren't originally designed to be that size, when you have larger plastic items that get into the environment and they break down, they can become microplastics over time. And then again, mentioning fishing gear. So that can be commercial or recreational gear that's lost, abandoned, or discarded. That image again is from top one is from Southeast Alaska, Dungeness crab pot, from a project we did. We'd love to do a similar one in the Bering. The challenge there is just the logistics of getting, you have to use sonar to find the debris. We'll talk about that more a little bit later. That can be challenging. But most of this gear is made with synthetic materials and metal. So at this point, when that gear goes in the environment, it lasts a very long time. Gear that maybe was being used, in the past, 100 years ago or more, would have been made of organic materials. So if it was lost, it certainly could have caused significant impacts. That's very potentially true. However, it would have broken down. Now the gear, once it's out there, really doesn't have an end date of how long it's going to be impacting potentially animals. So for gear like fishing gear, we refer to that as ghost fishing, the phenomenon that gear continues to catch indiscriminately for a long period of time. So what can we do about it? Removal, that's a key element of action. So cleaning up what's already out there. That's mostly people picking up debris. But disposal is also an important part and challenge in Alaska. We'll get into that a little bit more later. But prevention, stopping more from getting in the ocean in the first place. So helping people understand the issue and using different tools to meet people where they are and connect with people about the topics that they really want to hear and in ways that they can hear it. And then research, so learning more about where the debris comes from and what it does to the environment. That can be monitoring, lab and field studies, and experiments. And I wanted to highlight a few examples of some of these projects. I apologize for the little animation there, but the top left, that's cleanup actually in the Bering Sea region. There's been some amazing cleanups that have happened over the years. And there's been really great cleanup efforts. One thing I want to highlight here is the packing bands that you see there. That's an item that we see all throughout different parts of Alaska, from southeast all the way into the Bering, and can cause really significant entanglement impacts. I know folks who work in the entanglement element can really, recognize that and have seen it. The top right, that's cleanup from South Central Alaska. That's in 2011 through 2013 or 14, there was a lot of influx of debris caused by the tsunami that struck Japan in 2011, including a lot of foam buoys and styrofoam and other objects of similar types. So this is a large scale cleanup to do that. And on the lower left is cleanup in Southeast Alaska. We're looking at a lot of legacy aquaculture debris. So just examples of different cleanup projects in different parts of the state that have taken different tools and need to be tailored to the individual local conditions. Prevention examples, this is one I wanted to highlight. There's another project I'll talk about in a minute that's more recent, but this is one in Southeast Alaska, and actually this group in Southeast has also partnered with Park Service to bring some of their work up into the Bering Sea region. But Center for Alaska Coastal Studies out of Homer, they worked with local schools to monitor, actually capture, record how much trash of different kinds they created in each of these categories, and then they use that information to then come up with changes to make in the school locally. So they talked about, okay, well, wait, we're creating a lot of utensil trash or a lot of plastic trays. And then they looked at, raising funds to get a dishwasher or to replace, single-use utensils, plastic, sporks, with metal utensils, those sort of things. And then a small group actually went out to Augustine Island and did cleanup as well and used that data as well to inform future projects. Research examples. So this upper example was a project that was nationwide that included gathering data from parks, national park managed land throughout the country. And then they collected sediment samples and then quantified it for microplastics. So it was a cooperative project between NOAA, the Park Service, as well as Clemson University in South Carolina, who did a bunch of the lab work. And so one of the things that I found notable on that was that you had 2 sites in the Arctic. And in those, as Cape Krusenstern and Bering Land Bridge, I believe, and at those, you saw that there were the concentrations of microplastics in the sediment was actually comparable to National Park Service lands just outside of San Francisco and Boston, respectively. So it really showed that microplastics are making their way all around the world, and it's not strictly a problem associated with urban centers, but that it is being spread out, and areas that are far from these large population centers are still receiving concentrations of plastics. At bottom, it's an image from the crab pot survey in Juneau, or outside of Juneau, so in Southeast Alaska. We're looking at, so the bottom left, you see the track lines of the sonar, and actual sonar data. So you can see the crab pot there and that telltale halo shadow from the sonar data. And then actually using that to go down and collect the crab pots, count them, understand what condition they were in, and try to age them and see how long kind of impacts they could have. In that study, we actually found crab pots that were still catching crab over 7 years after they were lost into the environment. So it really shows just that gear that gets lost, even a crab pot, can really take a long time. One other thing I wanted to point out specifically were data collection. This has a direct linkage to this Bering Strait debris event that we're dealing with, because it's one of the things we're trying to work with. But data collection, getting a sense of what the debris baseline or what the debris picture is, and then also when things change from that baseline. Unfortunately, there is what we would hope would be abnormal, but at this point is quote unquote normal. There's a normal amount of debris that people are used to seeing. And one of the key things that clued us in to this debris event in the Bering Strait region recently was the fact that people said, wait, what we're seeing right now is well beyond what's normal. This is a lot of debris, and it's different types of debris. And that distinctive can be so critical. Because again, we'd all hope that there wasn't any debris coming ashore anywhere. But the reality that it has been happening, when things are different, that can also be a clue that something's changed and something needs to be paid attention to and investigated further. So there's different layers of type of data collection that's done. That can be something like opportunistic reporting. So that's kind of the first layer. So that's people who are already out in the field or for other work or efforts, whether that's hunting, fishing, or whether that's doing field work for science or whatever it may be. But then they're just reporting in what they see as they see it. That has a lot of advantages. It gives us coverage, ease of use. It's a low barrier to entry. It's an easy thing for people to do. It also is the challenges that it can be unstructured data. And also a key thing is the absence of data doesn't necessarily mean the absence of debris in those situations. Meaning if you don't get any data from a beach, does that mean that there was no debris there? It just mean that no one went there and looked for it, or no one was there and reporting. So that can lead to some challenges for you. One other way that we capture data is cleanup, categorization, and sorting. That's actually really been successful in certain parts of the Bering Sea. Northern Sound Economic Development Corporation has done great work with that, and using what used to be the MCAF, Marine Conservation Alliance Foundation forms. But basically the idea there is you go out and clean up the debris, you pick it up off the beaches, but then you sort it, whether that's right as you're picking it up. So, as you're putting it in the bags, you're saying, 2 bottles, 4 bottles, okay, one net, one buoy, or whether you bring it back to a central location and then do that sorting. So that can be a really important thing. So the advantage of that is you're already doing removal, so now it's just a little bit of extra effort, but it does add that effort as a negative, and the data can be a little more challenging. And the highest level in terms of kind of effort is shoreline monitoring. So actually going out and standardized counting of debris in a consistent area with a defined protocol. And that's kind of stereotypical clipboard science. So going out, counting stuff, and you have your flags and you mark out a quadrant and, transects, all of that. That has the advantage of giving you detailed information, and it's consistent methodology. So you can really get apples to apples comparison between sites across the US and even beyond. But it also does take a significant amount of time. And when field time is very limited, can be a challenge. So I want to highlight this because we'll get into this a little bit later. Part of the thing that we'd love to be able to do with any sort of debris event is having that context of seeing how much debris there is and how it fits within the overall picture. Okay, so getting into debris in Alaska a little bit. I think that the location of debris, we have hotspots throughout the state. This is a background image of debris that comes from different, the debris that is from an aerial survey of the state of Alaska, or for the Gulf of Alaska shoreline rather, that was done for the tsunami debris, so 2014, 2015. You can see they did get, at the far left, you can see they did get into Bristol Bay at that time. So this is not focused on this specific area that we're talking about today, but I think it shows an example of some of what we're talking about, where they have these hot spots where you can see debris that tends to show up in the same places on a repeated basis, based on the way ocean currents move and how they operate. So I think that can really, it's a key element of it. And that goes to the quantity. It's highly varied. You see debris that is in some places, but not in others. And that's a big challenge at times. Because you can have one beach that's getting a ton of debris, literally, other beaches are not. One direct example, Gore Point, where I mentioned earlier, in South Central Alaska, when it was cleaned once in roughly 2009, there were over 20 tons of debris in less than 2 miles of beach. And so some of these places can really aggregate a lot of debris based on the way the ocean currents and winds bring debris to Alaska. And another element that I think is notable in Alaska is this top left image, which shows the land composition, so land management responsibilities. Obviously, there's a lot of federal land in Alaska, and there's also obviously Native corporation, communities, there's state land, and there's also inholdings within all of those. And so really making sure that you're communicating with the right people for permissions, but also for local knowledge. So from a permitting standpoint and from a knowledge standpoint, it means that there's a lot of groups to work with, which can really lead to the best outcomes when you do that work and work with all the groups that you need to, but also can add effort and complexity. So that's just a kind of a little bit of background on the overall debris in Alaska picture. Now, one of the other elements is that how debris gets to Alaska. So one of the things that we point out is that Alaska, even on a mile per mile basis, obviously Alaska is the biggest state in the country, more shoreline than the rest of the United States combined. I'm sure everyone on the call already knows those factoids. But one of the things that is notable is that Alaska has some of the dirtiest, quote unquote, beaches that we see in the United States or even some parts of the world in general. even on a mile per mile basis, because of a lot of the open ocean debris that to Alaskan shores by wind and current patterns. And that can have an influence both in South Alaska, but also into the Bering as well. And so when it's coupled with local effort, especially. So you see kind of here at the top left, the Kuroshio current, which brings debris, becomes the North Pacific current, and then which branches south and then north into the Alaska current, which runs counterclockwise to the Gulf of Alaska. But then at the bottom left, that's a sea surface temperature image from Jet Propulsion Laboratories, which I feel like shows a really good example of just kind of, you have, the green being the warmer water, so blue being colder, and then pink being colder still. You have these areas of the currents moving counterclockwise, and then coming up through the Aleutians into the Gulf of Alaska. So that's just so one snapshot image. That's not intended to be what it always looks like, obviously, but it does kind of reflect the overall concept of that there is that connection, that debris that can make its way up in that direction. And another topic that I think is especially relevant to this debris event we're talking about right now in the Bering Strait region is the concept of windage. So where debris goes, where it ends up, is driven, of course, by currents, but also significantly by wind, which of course is very logical. But especially for higher floating objects, so objects that sit higher in the water and have more of a sail area and less drag underneath the water, of course, are more influenced by wind rather than currents. And so you can see items like, buoys, in this case, 3 different types of buoys, but in the case of kind of more common marine debris, something like a fishing net is really going to be much more influenced by the currents. It's going to move where the surrounding water moves. Whereas an object like a water bottle, especially one that's empty or only partially full, that sits higher and prouder in the water, is going to move much more rapidly and also be much more influenced by wind. And so, especially with some of the objects we're seeing in this Bering Sea debris event, or Bering Strait debris event, that can be the case. Sorry for the graphic there, but I want to also point out, this is data that was put together by the Marine Conservation Alliance Foundation back in 2000, and based on data that they did a really impressive project where they looked at data going back to the 1980s and all the reports that were available, and then also even going back and looking at newspaper articles and trying to then mine and find the people who've done the cleanup and get all the data sheets they could. So they put together this overall summary of debris items by count. And so the thing I want to draw attention to is just that really in a lot of the areas, there is a significant amount of debris in Alaska that is related to fishing efforts, whether that's international or local. And so that can really drive both the types of debris, but also some of the disposal challenges. Fishing nets and debris can be really hard to get off of beaches and out of the sediment if it gets submerged down. And I know there's been pictures and video I've seen from groups in St. Lawrence Island and others, trying to excavate these nets that they think when you first see it, it's just a piece of net, cut maybe a yard by a yard or something, and then you have to start to try to pull it out, and you have to excavate it into this massive net that's been buried in the sand or the sediment or rock, whatever it may be. That sort of in different places it can be different things, of course, but it really goes to this concept that when you have in areas where you're getting, broadly speaking, more debris items that are that have a high concealment risk, it changes the picture of what kind of debris you're looking at and what the risks are. So I mentioned earlier, the Alaska marine debris community. Below is just a sample of the partners who are active in the marine debris issue, but it's by no means an exhaustive list. So I just wanted to, I think, not the goal to have everyone read every single item on this list. And I apologize, the black dots don't show up as well. But it just shows that you have NGOs throughout the state, you have federal groups, state and local, and native and tribal organizations, as well as academic groups, including UAF Sea Grant, who's been kind enough to host this call and done so much great work on this event and other topics. But I think I just want to again highlight that Marine Debris Program, we're a member of this community and we try to support it. But there's so many people doing such great, amazing work on the topic throughout the state. So in the interest of time, I won't spend a ton of time on this one, but I wanted to highlight just, we talked about projects that, kind of pillars that get worked on throughout the state on the topic of marine debris, nationally, but especially in the state. So for us, there's grant projects or grant programs that the Marine Debris Program gives out money through every year. The first of those is community-based removal. As the name implies, it's communities get together and come up with an idea and apply to go out and do removal. So right now we've got a few projects that are active in those. So projects in the Pribilof Islands, Kodiak vessel-based cleanup. So volunteers going out to outlying islands, and then also people going out to the Alaska Peninsula to do removal. And then also they're doing accompanying research on disposal and recycling methods to try to understand better the best ways to dispose of debris. And that one's a recent one. And then prevention, we have work out of Homer. We already talked about the Center for Alaska Coastal Studies. But then we're really excited. We have a new project just got announced with North Slope Borough that they're going to be doing education engagement for next generation in North Slope Borough schools with a focus on local impacts and behavior change. So in a total of 8 communities in the North Slope Borough, they're going to be going out into the communities, working with teachers and working with the schools to build in curriculum and experiential learning, doing cleanups and data collection. We're really excited about that. Obviously, with schools being remote and different at the moment, and all of that uncertainty, and maybe that gets pushed back a little bit. We're working on that, but we're really excited about that project. I think personally I am as well. We're also working on Bering Sea packing ban pollution prevention. So really specifically looking at the issue of packing bans because of the threats they can pose. So working out of the Pribilof Islands, that's looking at engaging with the local industry and the fishing industry, as well as local community on ways to prevent the use of packing bans and identify alternatives and ways that can be changed. Okay, so I'm going to skip through this just based on the interest of time, but I wanted to focus in a little bit more on Bering Sea debris and how it fits in the bigger picture. So, again, quantities, it can be varied, from different locations within the Bering Sea, have experienced and received different types of debris and different amounts. You go to St. Michael's and Stebbins as an example. You have a lot of legacy debris. Working with a lot of legacy debris, iron and that sort of thing from legacy industries, mining and shipping and that sort of thing from old boats, that sort of stuff. So there's elements of that that's present. Then you have mixed with more recent debris. So there's different places that have their different debris types and sorts. But the available data that, again, going back to that study that MCAF did, shows concentrations that are comparable to the Yakutat region and the Bristol Bay region. So that study broke out the state into a set of regions, a total of 14. And so when you compare the Norton Sound region, the St. Lawrence Island region, and the Northern Bering, that's kind of 3 regions that they put together. That shows that sort of comparable. So it really shows that despite being in the Arctic and further north, that you're still getting significant amounts of debris. And this graph here shows kind of the percentages from those 3 regions averaged from that study. But again, something to highlight is just that you see significant amounts of fishing debris, but also a lot of general debris. So it's really a mixture of how much you see. So, and that's also an element of unidentified. I think that points also to the data collection component of sometimes debris, once it gets degraded enough, it can be really hard to see what it is and where it came from. So actions within the Bering Sea, cleanup and removal has been something that's been worked on for quite a while. I want to really point to NSEDC, Northern Sound Economic Development Corporation. They've removed over 1 million total pounds of debris from their projects, primarily in the Northern Sound region. And what would indicate. So, a huge amount of debris has been removed by communities and by community members over the course of years. Some of that's been through work with some with NOAA funding, but a lot of it with direct local support by Norton Sound themselves. So really, they've done an amazing work. But in addition to them, there's been really great work by local communities through other mechanisms, whether that's grants, but also direct work themselves. And then there's been the prevention work. We highlighted the new project with North Slope, but I know there's also been work by National Park Service. Actually, we're partnering with National Park Service to look at putting in some displays in different parks or visitor centers in Alaska related to marine debris, which I'm excited about. And then data collection and research. So National Park Service did that partnership project we pointed out already about quantification of microplastics, which included the Arctic and Bering Sea region, but also they've done monitoring. So going out and capturing debris data using different methodologies, including some projects that worked at integrating traditional ecological knowledge into debris surveys to do kind of cross comparisons of what debris surveys found with what was found or what would have been predicted based on traditional knowledge of where items historically washed up.
Peter, I've got a quick question on your slide.
Yeah.
I'm on a laptop, so I have a very small screen. Can you just list off kind of quickly on your pie chart, what are those categories for the green and the blue?
Yeah, of course. Sorry about that. And the colors are always, color schemes in those always come out a bit funky. So in this one, it's so trawl, seine, or cargo net, all line or rope, so differentiating line. Other fishing related, plastic beverage bottles, other plastic bottles, non-beverage, metal items, foam, and then other non-vessel related, which is a very high number. I wasn't able to dig into the report enough to really tease out, what that might have been and what drove that number being so high in this subset of the data. But I know that sometimes that points to categorization can be a challenge, especially in this case, they were data mining a lot of historical data. And so some projects, historically may not have broken things out in the same way. But that's a report I can, go ahead.
I'm sorry, I can't read it all. I'm just trying to find out what is the large green portion of the pie? What is most of the trash?
Yeah, that's other non-vessel related is what that's labeled as. So
Great.
And again, that in this case, I think I wasn't able to tease out from the report why that number was so high for this set of regions, the Norton Sound, St. Lawrence Island, Northern Bering. I think sometimes it can be driven by an individual cleanup that has a huge amount of weight or count in a given category. So there can be some outliers that drive that. But again, I think the other thing is it points to when you're dealing with data like this, sometimes the lumping and splitting can really have impacts down the road. If you end up with categories that don't quite align, you can end up with sort of these numbers that are a little bit trickier to interpret. But I think it points to overall, the diversity of objects that show up. It's not just one thing; it's a lot of things.
Thank you.
Yeah. So, in the interest of time, I'm just going to briefly touch on something that's going on, in general right now, which is also that this issue has been one of higher visibility internationally lately. So the Arctic Council, I'm sure many of you are aware of, but it's something that is an international body made up of member states, the Arctic countries themselves, but then as well as permanent participants and observer countries. So you really can have a lot of different countries involved, and they have topic-specific working groups, and of those, multiple. So there's 6 different working groups, and of those 3 and really 4 actually of those 6, so between half and 2/3 have active projects on marine litter, as internationally it's referred to. So we call it marine debris. Most internationally they call it marine litter, focused on putting together kind of a state of knowledge. What do we know about marine debris in the Arctic, as well as an action plan. So, okay, what can we do to learn more and try to coordinate better between the countries? And then also guidelines on how to monitor, so how to try to collect data about the issue. So some of the NOAA inputs we've been trying to put forward through channels to international, different offices of international affairs and the heads of delegation. We've been really trying to communicate the Arctic specific challenges and the difference between the Pacific Arctic and the Atlantic Arctic. So, it's kind of the Scandinavian Arctic, based on the presence of the jet stream and other forces, is ice-free significantly more of the year. So they experience different challenges, but also different expectations. And then also, differences in the regional impact concerns. So kind of the concerns that different people have are driven by those realities. So what does debris mean for a different community might be different if their economy is really tourism driven versus groups where it's really a food security issue. And then also really want to try to emphasize the importance of local knowledge, because of that being such a critical element for integrating into these elements, into these topics. When you're talking about knowledge from spreadsheets and from kind of stereotypical clipboard science can be certainly very helpful, but and important. At the same time, we really want to make sure that we're integrating the existing knowledge of what is coming ashore and what historically has come ashore or hasn't. So moving on, I'll try to switch to this more specific topic of the debris situation with the event in the Bering Sea, the Bering Strait region at present. So, as Gay noted, we're dealing with, a relatively recent, in the past kind of 6 to 8 weeks, pulse of debris. And I apologize, the resolution on this doesn't come through very well in this image, but I tried to just kind of create a map that showed kind of where we saw debris showing up when. So if you can see at least the colors, red dots indicate kind of a first group of sightings from the late July, so 27th of July, through the 3rd of August, so the first kind of week. And then the next group is orange, which shows sightings from about the 3rd of August to about the 14th of August, so next kind of 2 weeks. And then the blue shows more recent sightings, so the last month or so. And obviously these are approximate. And these are just the sightings we've had reports of, but it kind of shows an initial pulse or initial arrival at the end of July on St. Lawrence Island, followed a few days later by Nome. And then we had additional sightings in the Norton Sound and Bering Strait region, so spreading out. The debris types that were cited were a lot of beverage and liquid containers, also personal soap and hygiene products, as well. But we also saw aerosol cans, bottles of household and some industrial cleaners, as well as unidentifiable items that potentially could contain, household or shipboard hazmat. And instead of hazmat, in the sense of cleaning or oils or solvents, that sort of thing. But we also did see fishing relating items, so boots, bags, those sort of things. The bags, when I refer to that, Gay did some great sleuthing. We saw a lot of reports of blue bags initially, first mentioned on St. Lawrence Island, and Gay's help Gay did some great sleuthing, looking around at what those might have been and identifying those as potentially bucket liners. And for these, we mostly see Russian language labeling, although there's some Korean mixed in, and as well as even some English, but really predominantly a Russian language labeling on these items. But we also see fresh fruit and vegetables have been reported multiple times in multiple locations. So at Savunga, outside of Savunga, and also in Nome, we saw these items. So which really indicates items going into the water relatively recently, not having the chance to degrade. So what that kind of points to is likely a point source release. So kind of indicates a lot of debris going into the water at once. You can see the images at right, that have been reported and sent in. You see really, really fresh items. So actually, that item there at top left, J. Erickson, shows, actually, don't know if you can see it on your screens, but it shows a 20-11-19 date stamp. So that could mean a few different things. That could mean a date of manufacture on, late 2019, but could be all sorts of things. But I think one of the key things you point out is that that the age of that labeling indicates it really hasn't been in the water very long at all. It's something that's really hasn't had the chance to degrade. That looks like something you might have come off the shelf just a few days ago. So that really points to that. Additionally, we're seeing a lot of the same type of debris that also indicates a point source. So, a lot of the same classes of debris, these orange boots that Gay had submitted, that's one of the earliest sightings of them, but there's been many more since. Those have been kind of a signature debris item in this, starting on St. Lawrence Island and then spreading throughout the Bering Strait region. So again, that indicates a lot of one type of debris going into the water because of, we have less debris per area over time and distance. So meaning you have a lot of debris in that first pulse showing up on St. Lawrence Island, and then you still have a lot of debris in comparison. People are noticing it. People are saying, hey, this is different, but the densities are falling off somewhat. You don't have 20 or 30 boots in a mile. You have a group of 15 boots over many miles, something like that. So it kind of points to or indicates this point source release. So whether that's accidental loss or proper disposal or dumping, how could that be? But that's kind of where the active theory is. So in response to this, we've put together a working group. So it's been an ad hoc task force, folks from federal, state agencies, local community groups, the reporting groups, Alaska Sea Grant, COERIC, Fish and Wildlife Service, NOAA, Coast Guard, multiple others, to try to build awareness, share information, what we're finding, identify needs, and then opportunities for actions. What can we do about this? Some of that specific actions within that has been reporting systems. So that's included reports coming through Austin at COERIC and Gay with Sea Grants. And Gay put together this great poster, which has been circulated, which has helped drive reporting. We've also had established a NOAA incident email address. So people can report in to incident.debris@noaa.gov what they see. But then we've also tried to use hindcast model. So use oceanographic modeling to try to indicate the pathways of debris and try to better understand approximately where they might have come from. So that bottom right, you can see kind of a image of that. And I want to stress, these dots are not actual debris, but that's a simulated debris item. So the way the model works is you start with an initial assumed condition of, okay, the debris started at this point. Now you run it backwards and you simulate thousands of debris objects and sort of see where they clump, which could indicate potential sources. So that doesn't indicate clouds of debris. But what it shows is, okay, here's the clumps of where the debris might have come from. So what this does is it ran 16 days backward from July 27th, the first kind of reports. And so the likely source area gets larger as you go further back. And so this aligns with sort of this kind of the general picture of the debris source, even for Savunga, because there were strong northerly winds around that 26th, 27th, really showing that the most likely sources are over to the west and even slightly to the south of St. Lawrence Island towards the Gulf of Bonaire. So pursuant to that, we've also been engaged with the Coast Guard and NOAA International Affairs, try to identify best communication channels for investigation. So, okay, if we can investigate where this came from, is there a chance that we could try to match this up with AIS data and understand what vessels were in the area? That's something that Coast Guard could potentially do. But also for awareness, okay, can we make groups aware that, hey, this debris came ashore and people are keeping an eye out for it? And really with the goal of prevention, keeping this from happening again, reducing the chances of this happening again by connecting with different groups. So I know at this point, the Department of State has been engaged and has been engaged on the topic, as well as Coast Guard, NOAA International Affairs, and other groups. And we're trying to also look at what are the future next steps, whether that's the National Maritime Organization or other connections that can be made, because stuff gets lost off of boats. That happens. Accidents occur. But intentional disposal of any plastic material anywhere in the global ocean is illegal under MARPOL within the International Maritime Organization. So, this is something that if it's an intentional dumping action, then that's something that their rules were violated. And so there needs to be some way of trying to make people aware, hey, this happened and people were impacted. So that's one of the things we're trying to work through, is to really report it, model it, but then also try to engage to make those connections so people can be aware that it was noticed, and also ideally make connections with like-minded folks on the Russian side who may also be experiencing debris washing up and could report in as well. Not directly to the U.S. government, of course, but report it, what they're experiencing, and try to find ways to collaborate. And last but not least, one of the other key things we're doing is working to provide direct support. So we recognize the need to get direct funding support to communities that have been most impacted by this debris incident. So we're working on kind of focused or targeted grants to support response in the most immediately impacted communities, at least to start with. So Savunga and Gamble and Nome. So we've reached out to the tribal councils in those communities. Many thanks to Gay for many of those connections, as well as to Queric for their input and insight on that. But we're trying to find ways to support directly activities such as removal, so people's time in cleanup, fuel and supplies, disposal, but oftentimes disposal of debris can be challenging. So there's transport and disposal of the debris, whether that's local or backhaul. And then also data collection. So I mentioned earlier, but a core thing, a core element in debris for us is understanding the debris picture. So what kind of debris we see and how it compares to what's quote unquote normal in a region can be really helpful. And so we're working with communities to see if, during a cleanup, if they can count what they find and then be able to compare that, whether that's to historical data we might have from past cleanups. There's been a lot of cleanup effort out on St. Lawrence as an example, but also in Norton Sound and the Bering Strait region, in many locations. So how can we compare those? And then ideally, if we can do that again in the future, then we can start to get a sense of, is this a one-off, which, we certainly wouldn't hope it would happen in the first place, but, it's better to, it happens once, or is this something that's starting to happen more frequently? And if so, does that merit a different type of action to try to prevent it? And so we're working with those communities to set that up, which typically involves short application and then project management and tracking and then reporting. So really, kind of summarizing, our overall approach is to try to, better understand what's happening in the region with this debris event by, coordinating and sharing information across the different groups, what they're seeing, what they're experiencing, and what they see as the needs. And then try to fill some of those needs with examples like the reporting, the modeling, international engagement, and then also the direct support, so actually getting funding out to communities. So when we're hopeful to be able to do that as we work with the communities, and really we want to be community driven. So as we hear back from those communities on what they think they should do and how they want to approach it. As far as the next step of, well, what can we all do? What can you do? First of all, is people report in what you see. So if you see something out on a beach in the Bering Strait region, some inputs on what you can find on your beaches, with as much detail as you can provide, whether that's location, the date and the time, description, and representative photos. So if you say, hey, I see a whole lot of this type of debris, a photo of that kind of debris can be really helpful. And then also staying engaged, reaching out with questions on this event or on the debris issue in general, because we always want to be engaged with folks. I apologize, I had a photo here, but it doesn't seem to be showing up. So apologize for the white screen here. So with that, I know I'm just about time. So I wanted to open it up for questions from those who are online.
Great. Well, thank you, Peter. Let's see what the group has. I know I've got some questions, but let everyone go first. Anyone have questions for Peter on his presentation on marine debris? It was very interesting for me, hopefully for everyone else.
Hey, Peter. Thanks, Gay. This is Jill, Jill Pruitt with AUS. And I was wondering, I'm sorry if I missed this, but you had a slide there where you were showing 3 different time periods over the summer where marine debris has been seen. And I was wondering if if the composition of that debris was different in those 3 different time periods, or if it was kind of a steady type of debris that was washing up.
Good question. So I would say a few things. I think there are some differentials, but there are consistencies as well. So I think that in the initial pulse, and I'll actually, Gay can jump in at some point here, but the initial pulse on St. Lawrence Island and in Nome was really more homogeneous. There was definitely differences, but you had a lot of brand new water bottles, brand new food items, these orange boots, there was these blue liner bags. There's a lot of kind of similar items. Over time, we're still seeing those, but they're more intermixed with other types of debris. So that could indicate either multiple disposal events or loss events. So, dumping or loss, or that could indicate intermixing, which meaning that some of what is part of this pulse, this event, this loss of debris, this point release, is mixed with kind of everyday, quote unquote, normal debris. And again, those periods of time that are on that map, those were just kind of, I used those because it kind of naturally differentiated, and there was this initial pulse and then kind of it spread out over time. So that those weren't equal in time duration. So I wouldn't necessarily use those as like a, to indicate cohorts of debris or anything like that. It was just sort of ways. And also we did see additional reports from some communities, meaning Savunga or St. Lawrence Island, so Gamble and Savunga, have reported additional debris coming ashore since that first pulse, which could indicate, multiple different things.
Yeah, interesting. Thank you.
Yeah.
All right. Anyone have any other questions for Peter?
I do, Gay. This is Kim.
Hi, Kim. Go ahead.
Yeah, thank you so much, Peter. That was really interesting. And I was just curious, either Peter or Gay, have there been any, has there been an increase in any deaths of seabirds or marine mammals in the area as a result of all of this increase in debris?
Peter, you want me to answer that?
Yeah, I think that I'll take a quick step. I think, and Gay will know better about some of the marine mammal events and seabird events. I think there have been coincident, meaning people have seen debris wash up with seabirds as well. So it's difficult to say. We haven't seen, Gay can correct me where I go wrong, I haven't seen reports of specific animals impacted by these kind of the signature items that are associated with this pulse, meaning the water bottles, the boots, the bags, those sort of things. Now those pose their own threats, certainly, to animals, but we have seen. So it's sort of it's kind of a mixed answer, because there's not necessarily evidence that at least that I've heard of, and Gay may better, of these debris from this pulse impacting animals specifically right now. But there have been at the same time, ongoing events of seabirds washing up and other mortality events.
And I guess I would just add, Kim, that yes, we have an ice seal unusual mortality event underway here due to elevated strandings. But this year we have relatively the last few months very calm, low levels of reporting of dead stranded marine mammals. And the seabirds, though we have continued to have multi-species die-off, it's even also been less than 2019, more than normal, of course, but less than what we've experienced in the last few years. There's been no entanglement issues at this time. It's a great question. It begs what will happen in the future. So there are things that are washing ashore, like packets of packing bands and trash bags and bucket liners and things that might be ingested or easy to be wrapped in. And so, yeah, it does beg the question. We'll have eyes out, and we will certainly be reporting to the Pinniped Entanglement Group in Juneau, absolutely, if we have any sort of debris issues. We certainly in the Bering Strait region are surrounded with coastal community members that are experts, absolutely, in what is normal and what is healthy in marine mammals and seabirds. So hopefully, I really don't have too much of a doubt that we will hear if there is something untoward that's elevated. I really think that. So good question. It makes me nervous. And my question, I guess, to Peter that's related to that is, in these marine debris events that you work on, we know there's this much amount of debris that is, like you say, has the windage and is washed ashore. But when you see trash bags and other things, is there any estimate on how much is wobbling along below the surface that may be just entrenched on the bottom? Because this event is happening in a migratory corridor for marine mammals and seabirds and all manner of many. There's about 22 different marine mammal species that utilize the region, and it's incredibly important for locally for Chukotka and for the Seward Peninsula as food items. I mean, we're just sort of wondering, what is this doing on the bottom, the benthos? Is there any projection in the marine debris world?
Yeah, unfortunately, there's not really a simple answer of you know, a rule of thumb even for, you know, oh, if you see this much on the surface, then you assume this much on the bottom, because it's so dependent on the type of debris that was lost at the time. So you know, like as a direct example, estimates from like the tsunami, when the tsunami went ashore in Japan, from an inundation event like that, where like 70% of the debris that was mobilized, you know, by the wave sank near shore. We've seen that also in like tsunami or hurricane, you know, inundation events. But that's also when you have really high energy water mobilizing a whole bunch of relatively heavy stuff. When you're talking about other types of more typical items, especially in the Bering Strait region, you know, fishing nets are an example of something that can be dynamic in terms of buoyancy. So they can be lost and they can be, you know, neutrally buoyant, but as they become biofouled and degradation of that biofouled material, you know, animals incrustation, you know, or even animals that get caught, that can change their buoyancy. So they can then, you know, submerge and then, you know, resurface. There can be all sorts of things that happen. So unfortunately, there's not a simple answer of, you know, stuff, how much is on the bottom if you see X amount on the top. But certainly that we have seen examples, and there's a lot of examples in literature of, you know, the benthic environment certainly having significant amounts of debris, but it often being somewhat different than what you see at the surface.
Thank you. Thank you for that. All right, any other questions? I'm going to stop the share so we can see you, Peter, a little bit.
Okay.
There, let's see. Uh-oh, it thinks I want to share. I don't want to share. I think you have to do it at your end of things. There you go.
I just stopped.
Okay. Oh, all right.
Okay.
Don't know that happened. Any other questions for Peter Murphy from the region?
I have a question. I'm Kathy from KNOM. Thank you so much for your presentation, Peter. Let's say that this trash pulse is the only one of its kind in this situation. How long will it be that we'll be seeing the effects of this trash pulse?
It's a good question. Well, I think that the debris itself could continue to wash up for some period of time because, you know, what doesn't make it ashore, you typically need both currents to bring debris near to shore, then you need wind to actually push it onto the shore. So you can see that. But as we talked about earlier in the talk, debris that stays in the ocean, in the marine environment itself, can have other impacts. So, you know, a water bottle that stays out there can break down into smaller and smaller pieces that could become, you know, then available for ingestion by animals. So it kind of, the threat depends on the debris and its location. So, you know, a given item that goes in the ocean can be posing threats for a significant period of time, you know, years after it's lost. But what those impacts are is going to be very dependent on the type of debris. So I think that's part of the reason why, both for events like this and in general, you know, a lot of the focus we try to have is on understanding it, responding to it, removing it as much as we can, but then also trying to look to ways to prevent it. So whether that's, you know, for the chronic stuff that goes in the water all the time, that can be changing behaviors, you know, helping people to not use as many single-use items or dispose of them properly, you know, change packaging, all that sort of stuff. But for stuff like this, you know, potential loss or improper disposal, that can be more on the policy side of, you know, connecting with groups and understanding, you know, ways to change policy or change practices. So I think there's a lot of layers to it. So one of the things I think about marine debris as a topic is the threats of and impacts of debris are as diverse as the type of debris itself, and debris can be so many different things that it's, you know, the impacts of it can be very, very broad.
So Peter, if you can, anyone else? Kathy, did that answer your question?
Yes, it did. Thank you.
Okay. Anyone else for Peter? I was just going to mention that, you know, I don't know how much the marine debris program works in areas with ice, sea ice. And we've been sort of trying to think out here, what is different about this year? Of course, it's 2020. We got a lot of different things going on in 2020, but what in the marine environment is different this year? And some of it may be that we're having a tremendous open water period at the moment, wholeheartedly. So we may be getting different kinds of industry, different kinds of, you know, maritime vessel traffic that I'm not sure we're aware of yet, because we don't have access publicly to AIS offshore very easily here. There's a few novel industries that are working in the southern Chukchi this year. Looks like we're going to, then they may be able to be sustained, because it looks like from the most recent forecast that I've heard about a sea ice returning down from the Chukchi, which will effectively move the vessel traffic out of the area. It could be quite delayed this year in the fall because of the warm water coming along from the top of Russia and their extended heat event that they had in Siberia earlier this summer. So we may have a delay on the Chukchi freeze up. Is that, you know, for that earlier question about how long will this last, is that something that I guess we'll only know when we know? Is there any kind of debris event that's involved sea ice before, like this in Alaska or the U.S.?
Let's see. I mean, so as far as event, I mean, I think, you know, this for something like, you know, I'm not aware of another like improper disposal or loss or, you know, a point source release that potentially could interact with ice in this way. We certainly have debris that occurs in ice areas, you know, because of what we know about debris that's happened in the Arctic before. You know, so certainly I think it's a yes and no. So there hasn't necessarily been an event that I've been aware of that's been a point source. However, there's been a lot of work on that, and that's something that's been highlighted as a need area. Like, so in that Arctic Council work I mentioned, one of the things that's noted is the need to better understand how debris interacts with ice in terms of how that changes the transport of it and the behavior of it, because data has been collected, like in the Canadian Arctic, they've done ice samples and found, you know, microplastics in I believe it was multi-year ice. So there's the data that shows this debris is, you know, microplastics especially are getting to these areas. But how does that interact? What behavior does it change? And does the physical degradation of and the energy of the ice change how the debris behaves? Those I think are open questions, but certainly it's a layer of it, of course.
All right, thank you. All right, and thank you, Peter, because I had a lot of questions and you got other questions from the audience here. So thank you.
No, thank you. Really appreciate the opportunity.
If you could stay on the line while everyone else says their goodbyes or whatever, that'd be wonderful.
Great.
So
well, thanks everybody for your time.
Yeah, thank you all for coming to Straight Science. The next one will be tentatively October 1. We have the research vessel Oscar Dyson is heading up this way to do, which will be one of the few research vessels that is actually able to get information on our situation ecologically and environmentally in the Northern Bering Sea and Chukchi Sea. So we're hoping to hear from Jackie Grebmeyer or Phyllis Stabenow. Those are in the works. And then the one you don't want to miss is October 29th is Rick Toman, who will be giving us a forecast for the Bering Strait region regarding the sea ice arrival. So Peter, you're going to want to come in on that one, I think, and it might be of interest to you.
Yeah.
So with that, thank you all.